Right. Okay. So what we'll do is get back into the data that's posted on Moodle for these examples that for the data that you're going to use in your examples today that are for your homework. Oh, the other thing that I should announce is I did just recently post the third exam. So that third exam is on there. So that exam is not, that's due on Wednesday next week. So we will not meet or have a Zoom meeting on Monday. It'll only be if people have any additional questions about the exam or the homework that's not actually due until after you get back from break, this multiple regression homework. So this next Monday, we will not be meeting. And that I will be available if you have questions, if you want an individual Zoom meeting, if you're not understanding something with this stuff, that would be a good day for that, would be next Monday. I think Tuesday, by that time I'll be out of town though. So Monday would be the time to do it. Friday will be our normal optional homework, ask questions about the test day. So that's what we'll do on Friday. Okay, so let's go ahead and take a look. Oops, let me get to. Okay, so. Okay, so here, should be able to see my Moodle screen. Looking at the data on the Moodle screen that shows this male, female coded 1-0, count of adult arrest, count of juvenile arrest, attitude towards school. If the screen sharing is not working, just let me know. But I'm looking at the Moodle data here, and this is what you were to use for this first homework. It also is what you're supposed to use for the second set of homework, or the second homework that's not due until the 6th of April, where this one we are going to be entering in all of these variables at once, using adult arrest as the dependent variable for the multiple regression homework assignment here. And so in the previous assignment, I had you take a look at adult arrest and juvenile arrest, both as dependent variables, and I had you switching out the independent variables, putting in one at a time. That's what makes it a simple linear regression, is that you only have one independent variable entered in at a time. When you have multiple regression, you have multiple independent variables entered in to the regression equation. Okay, and so that's the major difference. So let's say, let's take a look at this when we run this as a simple linear regression. And so we'll do the first one, taking a look at the effect of gender on adult arrest. Okay, so that's what you would be looking for in your regression. So in order to do that, we want to go to analyze, and I've already got this data input into a data file. So I'm going to run a regression. Let me go back to, I'm on the wrong data file. I'm on the wrong one. Okay. What's going on here? All righty. See my screen. Let me try sharing that again. For some reason, that screen just did not want to share completely. Okay, well, anyway. Well, let me, oh, okay, geez, jumping around. Okay, so yeah, this is the data set that I cut and paste directly from the SPSS, or I'm sorry, from Moodle into SPSS. And so I just named these: gender, adult arrest, juvenile arrest, school attitude here, and here they are in data view. So let's go ahead and analyze regression. Oops. Sorry. Analyze regression linear. Okay, let me reset this. So we just want to look at this as adult arrest being predicted by gender. Okay, and so when we run that, let me stop sharing for a second and go back to my other screen. We get the results down here. So we see that we have the effect of gender on adult arrest is right here. Here is the beta for the effect of gender. And so how do we interpret that? Well, we interpret that as a unit impact interpretation. For every unit increase in gender, that's how much adult arrest is expected to go up. We would know that we're talking about the difference between men and women, because when you go up in a level in gender, gender is measured 0, 1, and so that is the effect of gender, but it's also showing you the difference between the estimated difference between men and women, and so the effect is positive here, and it is statistically significant. And so your beta, your unstandardized beta is 2.40. That is the size of the effect in terms of the unstandardized beta. Some people gave me the R statistic, which is okay in a simple linear regression. That is not okay, though, when we get to multiple regression. When we get to multiple regression, the R, this main R, is no longer interpretable because you have multiple things affecting it. And so you have to go to the unstandardized betas. When you want to use the equation and find predicted values, you use the unstandardized coefficients. Okay, so this is what we want to be plugging in for B in our equation. The constant is what we plug in for A. That is called, that's the y-intercept. That's what we plug in for A. Now it's called the y-intercept because that's when the regression line is expected to intersect with the y-axis. But that is what we plug in for A in the equation. So it would be 0.6 plus 2.4 times x, and so x can take on one of two values here, either 0 or 1, and because that's men are 1 and women are 0 on this, and so that is how we make a prediction about what is the predicted number of adult arrests for males and females. Okay, so what we would do, define that, just going over this, we would want to go to, let me, oh, sorry, yeah. Let me open up my Google window. Yeah. Okay. So to solve that, you just plug in, oops, got it in there already. So we would be using this equation, 0.6 plus 2.4 times 1. Oops. Let me go back to that. Times 1, which equals 3. So the number of adult arrests predicted for males equals 3. Okay, and so if you'd want to find it for females, you'd have to change our X value here to a 0. And you find that the number of predicted arrests is actually less than 1. There's predicted less than 1 arrest, and so it's lower significantly than men. That is how you find for predicted values, okay? And it's important that you make sure that you're plugging in the right values to do that. So just make sure that that is what you're doing. And that whole process continues when we get into multiple regression. You're just adding more B's and more X's to be added or subtracted from the constant. It's just a continuous addition, subtraction, arithmetic problem. That's all it is. And so you just keep adding B's and X's when you have multiple predictors in the equation and multiple variables associated with those predictors, with the B's. Okay. So let me stop sharing that and go back and let's do another one. Let's go to the effect of juvenile arrests on adult arrests. Analyze regression linear. Also, folks, just make sure that you're going to linear regression. This is the idea of minimizing the spread of the data, or the observed data points, the differences between them, by drawing a line that minimizes those differences, that best sums it up. That's why it's called ordinary least squares regression. It's called a linear regression because it's assumed the regression line is straight. We are doing a simple linear regression here because it's just the one predictor. So let's put the juvenile arrest in there and examine that. Okay. And so here we have, let's talk for a moment about, again, what R square is. And so the R square value here is 0.99. And so that's saying that 99% of the variation in adult arrest can be explained by juvenile arrests. So if you know somebody's juvenile record, you can predict with almost 100% accuracy how many adult arrests they're going to have in the future. Completely unrealistic. That's because I just made up this data. But nonetheless, that's what this model is saying. And so that is the R square statistic. That is the one you look at when we have just one predictor. Okay, when we have multiple predictors, we're going to look at the adjusted R square. But when you just have one predictor, you look at for how much the variation is explained in an outcome. Okay. Again, we have this ANOVA, which shows an F test, and the F test again is just saying whether or not there are going to be any significant predictors in the model, the regression model that you ran down here. So, you know, it's simple to see that if you have just one predictor, but if we would have, 100 predictors in there, some are not going to show significance, some are, and just looking at the F kind of gives you a sense of just how strong the model is overall with the predictors. And F also gives you a sense if how much, if you're explaining a significant proportion of the variation, if it's a significant proportion explained. And so 99%, I would say that's statistically significant. Then finally, we get back down again to these beta coefficients here. And so this is the effect of juvenile arrest on adult arrest. And so what this is saying is that for every additional juvenile arrest, the predicted number of adult arrests is expected to go up by 0.348. So it's important that you get comfortable saying that unit impact type interpretation. So the generic way of saying it, every unit increase in X has this effect on Y. Here you can say for every additional juvenile arrest, adult arrests are predicted to go up by 0.348 arrests. Okay. And so, yeah, to go up a whole additional arrest, you'd have to be arrested about three times as a juvenile suggested by the model, because it's not quite equal to, it's a third of an arrest here. Okay, and the effect of this, so that's the strength of the effect, 0.348, it's positive, and it is statistically significant. Okay, so B's are on the T distribution, and so they use the T distribution table to look to see how significantly different that is from having a zero effect. The effect, it's testing it if it's different from zero, and so yeah, that's statistically significant. Okay, the p-value is 0.000. All right, and so that is what we find when we look at the effect of juvenile arrest on adult arrests. And now finally, let's look at the effect of school attitudes on juvenile arrests. And so this is in the homework, I'm asking you to look at these all at the same time, but right now we're just looking at these individually in simple linear regression. So analyze, linear, and put juvenile back and stick in school attitudes. Okay, this is the kind of thing you'll be asked to do on the exam, because on the exam it just has you doing simple linear regression, one independent variable at a time. So that's what we're doing. We're keeping the same dependent variable here in this case, but switching out the independent variable. Okay, and here again is another regression. Okay, so what this is telling us is that school attitudes by themselves explain 0.635 of the total variation in adult arrests that are observed. So R squared can't be higher than 1, so that can be interpreted as about 63.5% of the variation in adult arrests can be explained by variations in school attitudes. All right, and so we go down here again to the coefficients, and notice we have a negative B. What that means is that the relationship between the school attitudes and adult arrests has a negative correlation. And more specifically, for every unit increase in school attitudes, adult arrests are predicted to fall by 1. So for every unit increase in school attitudes on that scale, if you look back at that Moodle data, it's 1 to 5 scale. 1, you hate school, 5, you love it. And so as you go up in those units, so if you go from a 1 to a 2 in school attitudes, your predicted number of adult arrests falls by 1. If you go to a 2 to a 3, it falls by an additional 1. And so it's linear. It's the same thing all the way up the scale. So it's linear in that sense too. We're not, the predictors are linear. And so we're not at this point thinking that it's curvilinear, that if you get to a certain point, the effect of school attitudes on adult arrest has diminishing returns. No, it's always for every unit increase in school attitudes, adult arrests are predicted to decrease by 1.03. Okay, and so that is the unstandardized effect. This is a significant effect. Now the T is negative because the beta is negative, and so T's the strength of the T, you want to think of that in absolute terms, because a -3 is the same strength as a +3 in terms of the T-test, and that is also statistically significant. Okay, so we've got 3 different predictors: school attitudes, juvenile arrest, and gender, all of which are significant predictors of the same outcome, and all of them are explaining. So in this case, gender is explaining about 52.2% of the variation in adult arrest, just gender all by itself. Okay, so clearly this is a case where we want to try to figure out, okay, which matters more, all else being equal. We need to account for the fact that males are just more likely to be arrested. In addition to the fact they're more likely to have a more extensive juvenile record and less likely to love school compared to the women in the sample. And so in order to assess these things individually while adjusting for other factors that they all happen to be correlated with, then we have to go to multiple regression. Okay, so this is what is going on for the homework. Is you are taking a look at all these variables, but putting them in the equation all at the same time. All right, so we go to where it says analyze again and go back to regression, and we go into where it says linear. And let's go ahead and just start it over with gender. And it does not matter what order you put these in, doesn't matter at all. Gender, juvenile arrest, and school attitudes. Okay, so now we have a regression model, as they say, a multiple linear regression model with adult arrest as the dependent variable, gender, juvenile arrest, and school attitudes, all as being simultaneous predictors of adult arrest. Now we know gender, juvenile arrest, and school attitudes, they're all correlated with one another. So we can see that just by eyeballing the data on Moodle, right? You can just look and see, yeah, the women have had a more favorable attitude towards school. They have fewer juvenile arrests and fewer adult arrests. So we can see that all of these things, the independent variables, are also correlated. So we need to tease that apart. Okay, that is the what's going on in multiple regression. We're teasing the effects of these things apart because they share overlapping variations with one another. So people who are, the same people who have lots of juvenile arrests are also the same people on average that tend to have negative attitudes towards school, and those people tend to be disproportionately male. So you have all that jumbled together, but we want to pull that apart and see what independent effects there are, if any, to these variables. Okay, so we go ahead and hit OK, and we will see what happens when they're all in there. All right. Okay, so notice in the model summary, now because it's a multiple regression, you want to look at the adjusted R-square. And so that is saying that this model explains about 98.8% of the variation in adult arrest. Okay, so you can't, it's very difficult to get much better than that. Okay, so this is because I just made the data up, but nonetheless, that is what it's saying. It's saying that that gender, juvenile arrest, and school attitudes collectively explain about 98.8% of the variation in adult arrests. Okay, so that's what you read off when you're looking at the multiple regression, because R-square can increase even just slightly when there are predictors in the model. They're not even statistically significant. They just may have an effect size that pushes the R-square up by itself a little bit. So that's why the R-square, adjusted R-square, the way that the math works, it adjusts for that. Okay. So down here, look now what we have. Okay, what we can do with this, because we have multiple predictors, we can use the standardized beta coefficients to answer the question of which has the strongest impact on adult arrests. Okay, and the standardized beta coefficients, you interpret these in absolute terms, so it doesn't matter what the sign is. You just look at what is the biggest effect. And clearly here, juvenile arrests overwhelmingly has a stronger impact than gender or school attitudes in this model, because the standardized beta coefficient is 0.949. And because it's standardized, what that means is you can interpret this now in units of standard deviation. So for every standard deviation increase in juvenile arrest, that adult arrests are expected to go up by almost one whole arrest, because it's on a standardized scale now. So everything can be interpreted in standard deviations. But they also have this nice apples to apples comparison. Okay, that's probably more important here, that the apples to apples comparison. So you can tell without a doubt that juvenile arrest is really the thing that matters. Although we saw originally, yeah, these things are correlated. The data were not lying to us. We were not hallucinating. Gender and school attitudes independently do have an impact on adult arrest. However, after adjusting for juvenile arrests, the effects of gender and school attitudes are no longer statistically significant. So we notice here, this is not statistically significant, and this is not statistically significant. Now we can still use the unstandardized betas to make predictions about the number of adult arrests. So we can say, okay, what is the predicted adult arrests for a male with a certain number of juvenile arrests and has a certain attitude towards school. So you could do that, and what you would find is that just by looking at the standardized effects alone, that this is going to have a much the unstandardized effects. This is going to juvenile arrest is going to swamp everything else in its impact because it's larger. Gender is still going to have some of a effect on Y. You know, it is 2.07, but you can only plug in a 0 or 1 there. So this model is going to be used nonetheless, even though there are two insignificant or non-significant predictors, to make a multivariate or multiple regression prediction about adult arrests. Okay, and so this is also perhaps a case here of mediation, something we talked about when we first talked about multiple regression, because when we have juvenile arrest in there, by itself it's significant. All of these are when they're by themselves, they are significant. But if you add juvenile arrest after gender is in there or school attitudes in there, the effect of either school attitudes or gender will go away. So let me show you. So we saw the effect of what school attitudes is. It's negative and it's statistically significant. If we put in juvenile arrests, though, we find that now the effect of school attitudes, the actual, the beta effect, the size of the beta has been reduced here to 0.037. It was originally, if I just scroll up here, a negative 1.03 when it was in there by itself. However, in a multiple regression, the effect is diminished to a 0.037, and now it's no longer statistically significant. Juvenile arrest is statistically significant, and by far. Okay. So what does that suggest? Well, it might suggest that juvenile arrests might be in part a function of school attitudes, or vice versa, really. It might be that people who are arrested a lot as juveniles are going to be, on average, more likely to have poor attitudes towards school. We know delinquents don't like school. They don't like anything about it. They don't like paying attention. They don't like the authority in school. And so Why is it that school attitudes have an impact on adult arrests? Well, that is because kids who are highly delinquent tend to have poorer school attitudes, and vice versa, those who are non-delinquent tend to have positive school attitudes. And so juvenile arrest explains away the effect of school attitudes. That's what you call a mediation effect. It is explaining the effect of one thing with another variable, both of which are closely correlated with one another. So if you look at a correlation between school attitudes and juvenile arrests, those two things will be correlated. And so you have to account for that. So we can see the same thing again happen if we go to analyze, regression, linear. If we put gender in there and juvenile arrest. Okay. And we can see from the model, the simple linear model, where it just has one gender as the predictor, the effect of gender is diminished by juvenile arrest to a 0.204 from a high of, where was it when it was just by itself? Let me find it. A little bit further up here. Yeah. Originally, there was about a 2.4, about two and a half arrest difference on average predicted for males versus females, gender by itself. But what accounts for the difference in predicted number of adult arrests between men and women? Well, it's probably because they have very different juvenile arrest records. That's what accounts for the gender effect on adult arrest. That's another mediation effect. So this is where you start, this is the quantitative reasoning part of the course, where you're trying to tease apart this rat's nest of social science variables. A lot of them are closely correlated with one another, like arrest records as juvenile and gender. And well, what happens when one thing is then accounted for or controlled for? And then we can see, well, what is possibly explaining the gender effect in adult arrest? It's probably just a reflection of the higher rates of delinquency among boys. As shown by the fact that the gender effect is mediated or explained away by when we put juvenile arrest in the model, because it's significant here, but gender is not. Okay. And then we can go further into this. We can ask the question, well, do school attitudes mediate the effect of gender, or is it the other way around? Do they have any impact on one another in terms when they are put in the model? So we can check out that also, just so you're kind of diving deeper into what's really pushing things around. So we're just switching out school attitudes with juvenile arrest and seeing what gender. So what we have here is the effect of gender and the effect of school attitudes. Both are statistically significant when they're in the model together. So although both are also slightly smaller from when they're in the model by themselves. So if you look at school attitudes by itself, right here, it's negative 0.786. I think it's smaller. Yeah. By itself, it's a negative 1.03. So gender does partially mediate the effect of school attitudes. And look, the effect of gender is also a little bit smaller from where it was 2 something. And it also partially mediates the effect of that. But they're both still statistically significant. So we can kind of determine then from the sequence of models that we just ran that it really is juvenile arrest record that seems to be capable of explaining the effects of both gender and school attitudes on adult arrests. It's not that school attitudes explain away gender, or gender explains away school attitudes. They don't. They're both significant in the model. With both of them in the model, about 78.8% of the variation in adult arrest is explained, so they're very important. It's just that they are probably both a reflection of juvenile arrest record, or a function of juvenile arrest record. And so because of that, you see when they're all in there together, the significance goes away. Okay. So that is a little bit more on why we want to do multiple regression in addition to just looking at individual variables entered into the model one at a time, because you will notice that the effect of the B's, the beta effects will change, and we can then also assess what that means theoretically, like if you think that one thing is explaining something else. We can assess here also what I didn't mention, is the standardized beta coefficients. We can make comparisons on which is stronger, though. We can make an apples to apples statistical comparison. And school attitudes turns out actually to be stronger than the effect of gender, because it's a negative 0.608. So remember, you interpret this in absolute terms. Forget that there's a negative there for the standardized betas. What number is bigger? The effect of school attitudes, that number is bigger. And so in terms of interpreting it as what effect has the strongest, what has the strongest impact, what has the strongest effect on the dependent variable, it's in this case, it's school attitudes. Okay. And here, if we look at it for gender and juvenile arrest, it's clearly the case that juvenile arrests have a stronger effect than gender does. But be clear, these standardized beta coefficients are not the ones that you use in your equation. The equation y equals a plus b, a plus bx, sorry. These are not the ones you use in the equation. You would use these b's over here. It's this whole row right here that you would use in the equation. Okay, so that's just, again, I'm just making sure people are not accidentally plugging in the wrong values here for these effects. Okay, and so are there any questions about that, about what we're looking at, the difference between simple and linear regression? Okay, and so yeah, so let's take a look back at the homework here for a moment. Okay, so yeah, if we take a look at this one, what is the predicted arrest count for a male who hates school and has 15 juvenile arrests? All right. Well, we're to use the data that's up here, that you're supposed to cut and paste that again. So male is 1, and then a juvenile arrest record of 15 arrests. It doesn't matter, by the way. Like if 15 really wasn't in here as a number, as an actual observed count, it doesn't matter. I could say estimate it for 14, for example, and that's still legitimate to do in regression because it is an estimate. It knows what it is for 13, it knows what it is for 15, so it can estimate what it would be for 14, a number in the middle. And so that's true all up and down the scale. And so it doesn't matter that you don't actually have an observation for a juvenile that has 14 arrests. I just happen to be picking one that has an observation for 15, but it doesn't matter. So it's perfectly legitimate to estimate it for like 2 arrests. I'm sorry, not 2, but 2 is on there, but say something like 17. arrests. You could extrapolate beyond the data a little bit, but not by a lot. You wouldn't want to do it by like 100 juvenile arrests. You're looking at that. An attitude towards school, 1 is hate it and 5 is love it. Okay, so we always want to keep in mind what is the range of values that we can plug in for our X's, right? So we don't want to plug in values that are way outside of the range or just not a possibility of what we can plug in for. And so this would be, your, if you arrange it like this will be your first B for gender. Your second one would be, school attitudes, if you set it up like that, and third would be juvenile arrest. Okay, so if we go ahead, I'll just rerun this. Oops. This back. Okay, so we have school attitudes and juvenile arrest. Okay, and so we run this. Okay, and so here is our equation. We want a negative 383 for RA, and first B is 0.207 for gender, and then a negative 0.004 for school attitudes, and then we have a 0.332 for juvenile arrests. Okay, and so we want to go ahead and plug those into our equation. Okay, so we have a negative 0.383 plus a 0.207 times our first X, and this is the X for gender. The effect for gender is 0.207. Am I correct? Did I do that right? Can somebody confirm? Let me just check back. I want to. Yes, 0.207. Okay, so gender can take on one of two values, and we want it from men, so we put the 1 in. Okay, and then we want to then do plus a negative, put it in parentheses, 0.004. Oops, I forgot to put my asterisks in there. Google won't like that. This times he hated school. Okay, so we put a 1 in there for that. He hated school. Plus a 0.332 for the juvenile arrest effect. And that, what did I say, times 15, because we want it to be for 15 arrests. Right? Okay, so yeah, let me double check, make sure the effect for juvenile arrest is, 0.332. Okay. So this is estimating what the effect of these variables will be on Y, the outcome. So this is the predicted number of adult arrests for a male who hates school and has a juvenile arrest record of 15 arrests. Okay, and so when we have that all in there, you hit enter. Okay, and so it turns out that his predicted, for that statistical profile that you can think of as a statistical profile for somebody that fits those attributes, the predicted adult arrest count is 4.8 arrests, almost 5 arrests for that person. So that is how we do it in multiple regression. It's just the arithmetic just continues. So you have, here's your first beta. So this is B1, X1, B2, X2, B3, X3. And so that's the formal way of writing it out. But, you know, you just make sure that you're keeping your betas straight with the X values that you can multiply them with. And so we multiplied this by 1 because we wanted it to be male. If we want it to be female, then we have to flip the values to whatever. So for female, you flip this to 1. Who loves school? Flip this to 5, and then what's the arrest record that I'm asking for? Somebody tell me. What is it? Two juvenile arrests. Okay, folks. Oops. Okay, so you know, an arrest count of less than 1 is expected for someone of that statistical profile for adult arrests. Okay, so that is class for today, folks. And if there's any questions, you want to stick around for a couple minutes, that's fine. But that is it. I will be Zooming with you on Friday if you'd like to discuss any of this stuff. But that's all we have time for today. Okay, so bye-bye. Have a good afternoon, and I'll see you on Friday if you want to discuss any of this further. Okay.